acceleration A, then it will undergo retardation B. For time t, it will accelerate. Then for time capital T, it will retard. It was at rest particle. Again, it will come to rest. Let it acquire a velocity, say v1. Let u be the average velocity in this case, and x be the total displacement. X is the total displacement is telling. So this distance covered, let it be S1. S2. So here it will be T, and this time interval will be captured. I think this much is the information what in the second case, it is accelerated for same time T. Let's see what all equations. Again, the particle will start from rest. It will come to rest. It will accelerate for same time. Definitely the distance covered has to be different. Okay, but the time will be same. You can call this is x1, this distance x2. Call this as v2. Then it will have retardation B. I think the data what all available is what I have just put it. Let's see what all we can do with a constant in time t. If v is the average velocity in this case and y the total displacement, then so what is x? X equal to s1 plus x2. Y is equal to, I think I'll change symbol. R1, I'll write it. Yeah. We have to show that how those quantities are related. Okay, first we'll write what is x is equal to. Let me write equation. X should be equal to s1 plus s2. What is s1? A t square by 2. Then what about the s2? S2 should be equal to v1 t minus b t square by 2. Okay, I'm showing it. Now, what is v1? V1 should be equal to at. Let me substitute that. At square by 2, at capital T. This is what x. Similarly, we'll write the expression for y. Y is equal to R1 plus R2. Before that, what is V2? V2 should be equal to 280. Then what is y? R1 plus R2. R1 should be equal to 2a t square by 2. What is R2? V2 capital T minus b t square by 2. V2 will be 2at. Okay, no. What to do with the after this? So some comparison, something is asking, no? How x and y are related. So at square minus bt square. This I'll expand it. We'll see what do we get it. At square. This only at square plus at square. A small t capital T, a small t capital T minus b t square by 2. So a t square by 2 in place of this, look at this quantity. a t square by 2 plus a small t capital T minus, I'm highlighting it. Look at that quantity here. And let me put this too. Okay, can you say anything about? So can we replace this here? So altogether, what is y is equal to then? Y should be equal to x plus at square plus at capital T. Definitely. I think, okay, fine. Yeah, this will be bt square will come. So at square, this one. So y should be greater than x. What about the relation between v and u? What is the average velocity? Okay, let me work out here in this part of the region. What is the average velocity u? U we define it as x by t plus t. V we define it as y the total displacement. So y will be t plus capital T. Okay, we'll agree this. And we have shown here, we have equation that v by u will write it. So this will be y by x. Since y greater than x, so therefore v should be, y will be greater than x. So with this, what we can write it as, v should be greater than u. It's a simple analysis, nothing big. Somehow if we can student draw this, the motion, okay, how that motion takes place, if we can think once, that'll be sufficient. You can really manage the problem. This diagram is very important. Please, all of you, in whichever institution you are learning, irrespective of whatever teaches, there's a very general thing. The moment you read question, you can't write formulas. If you have this diagram, looking at diagram, writing formula very easy. Please do learn. I don't want to work out more numericals. I want to convey a method where student can solve more numericals on his own. After reading question, draw this diagram like this, how that motion occurs. So it is at rest, it will accelerate, then with an acceleration A, then it will undergo retardation. So then it will acquire velocity. Then with this velocity now start decreasing, comes to rest, indicate B, retardation, acceleration A, it will cover some distance. This time is given. Okay, now looking at this, you can write all this equation. Distance covered during accelerated motion, distance covered during retarding motion. You see this? Anybody can write what is there in this? Let me move to the next question. If you want, you can plot the graph also. Okay, let me show that also. So I'm very particular about learning aspect here, not something dumping aspect. First, it will accelerate. So you even through graph also, you can work out this problem. Which graph we should plot? Position versus time. It will accelerate. Then it will undergo retardation. Then what happened? Acceleration is twice no, so therefore definitely. I think okay, this one I'll come with this one. Below this, let me plot it. Comparisons will be easier. Okay, this. The time of journey is same. Only thing is the velocity attained will be different. Let me choose some color. Yeah. This time is same. The velocity acquired will be different. Here v1, this will be v2. I think it's very simple. No, the area under VT graph, what it will give, the distance covered. So look at the area of the triangle. They are different. So definitely you can expect average velocity to be different. V2 greater than V1. So what do you expect this area? This area will be less compared to this area. That's what I'm showing. You can look at the diagram. The area under this curve is more than this one. So you can straight away write this information like if this is A2, this total area is A1, A2 greater than A2, A1. But the time interval is same. Time of journey is same. So what is the average velocity distance got by time taken? We can draw even these things also. You can work out even using this VT graph also.